All right, so today we're going to be talking about object-oriented programming and what that means and all the little intricacies of object-oriented programming. So the things we're going to be talking about is objects themselves, classes, information hiding, encapsulation, inheritance, and polymorphism. Now there are a few more things to object-oriented programming that aren't going to be covered in this lecture, but will be covered in later courses. So just keep aware of that. So what are objects? Well, they're the core of object-oriented programming. Basically, it comes down to a bundling of data and behavior. So variables as well as functions. So by behavior, we mean like things like actions that the player can make, or behind the scenes functions that you need to run, like math or algorithms, right? So, what kind of data do objects store? Well, you've seen all this stuff before. So ints, floats, bools, objects, arrays, lists. Objects and arrays and lists are, containers. So objects themselves you can store inside of other objects, which again is just a bundling of data and behavior. So think of it as a container. And then arrays are containers for all the other variables. You can even store objects into arrays if you wanted to. And then lists are similar to arrays, but they work a little differently. So other things that they can store are methods or functions, which can be used to access and manipulate data of an object through accessors and mutators, or properties in C#, or just straight up functions, right? So classes are a way to create objects. So we use classes, and they have a unique identifier. They come with a class name that you can write out to anything you want. They store variables, they store functions, and they use to manipulate the data of the class as well as perform some sort of action by running a function. Each class has a programmer-defined variables and functions with unique protection levels. So each variable has a unique name, each function has a unique name, and all of them have some sort of unique protection level. In C#, they default to private, and that's the way with most languages, but not every language. They default to private, which means that they cannot be read outside of the class. They cannot be modified outside of the class, whereas public functions and stuff like that can be read and can be invoked outside of the class. And then you create instances of a class by calling the constructor, and each instance is unique, meaning that the values for each of the data members and each of the functions are unique to that class. Information hiding, so that's our protection levels. So we've got public, which allows access to everyone. So anybody outside of the class can read the data. They can write to the data. Hackers typically use public variables to get access to certain systems. So it's best to use private when dealing with variables and functions and stuff like that. So where you can or where you have to, use private, but use public sparingly, and use protected as needed. Okay. So private means that you can't get access outside of the class. You can only manipulate the data within the class, which is awesome. It's a great thing to do. So make sure that you set your variables and your functions to private by default. And then if you need to get access outside of the class, then you can change it to public. And then protected allows access to children. So when you protect a variable or a function, only children can invoke those. They can't be accessed outside of the class. So it's a mix between the public and private. And why is this important? Well, like I said, it prevents unnecessary changes to data. So when it's public, anybody can just put whatever they want for the value of a variable or function. They can even put corrupted data there, which would be a bad thing. It would cause errors and cause your programs to crash and stuff like that. So like I said, use private where you absolutely need to, as well as make that your default setting for protecting your variables and functions. And then only allows access to data from certain classes. So that's also important because we don't want certain classes to have free reign over our data. We want it to only be able to change certain things. So by using information hiding, we determine that access level. All right, so moving on, encapsulation is, well, it's a bundling of data into one class. So it's kind of like an object, but it is more like it holds a bunch of different objects, right? Each having their own behavior, and it's all bundled into one class. So think of, like, if you ever heard the term API, that is encapsulation in work, where it's a bundling of data into one class, which allows them to manipulate some sort of system. Typically, like DirectX, you'll have an API for, or some sort of sound card, you'll have an API associated with sound information or something like that. Uses information hiding, so it protects its data, which is important, and they do have accessors and mutators. Getters and setters are the same exact thing as an accessor and a mutator. It's just a different term, so I just want you to be aware of what those are here. And then inheritance. Inheritance is like a hierarchy of classes. It's how you get behavior passed between each class. So you'll start out with typically a base class, and it'll have all the functionality related to all of its children, all the common functionality, I should say. And then each class inherits from that, will have access to all of that functionality, all those variables, all those functions, but then they'll be able to implement their own version of some of those functions if they wanted to, through overriding. So you can inherit classes way down if you wanted to, so on and so forth. Great grandparent classes if you wanted to make it that way. It's totally doable. So pretty cool stuff with inheritance. Why is it important? Well, it's used for program-wide manipulation. So usually we'll create a interface, or we'll have a base class, which allows us to access a wide set of data relatively quickly. By using that base class, we can tell the system to give us all the classes of that type, and then we can do things like rendering and collision. So if a rendering system uses a base class of like a renderable object, then anything that gets drawn to the screen will derive from that, and important things like getting the vertices in the right place and so on and so forth can be done through the rendering system. And then collision does that as well with all of its collidable objects. So when you derive all of your physics objects from some sort of base class, then you get those functionality for handling sphere-to-sphere collision, or box-to-box collision, or some more advanced collision if we went that route, right? And then having a class inherit from another class means that the derived class receives all the functionality of the parent class. And through overriding, they can change that functionality, or they can add additional functions if they wanted to add more functionality to the inherited class. Okay, so that's inheritance. Polymorphism is basically treating one object as another type of object. So typically done through like base classes. The example I like to use is vehicles. So there are all kinds of vehicles out in the world, cars, motorcycles, ATVs, so on and so forth, right? But each of those cars, motorcycles, and ATVs are all vehicles, right? So you can treat all of them as a vehicle and access the data of a vehicle as well as the functionality of a vehicle for each of them. Now, the way they implement those things, so like a motorcycle doesn't have any doors, right? But a car does. But they do have like a gas pedal, and they do have a brake, and they do have some common functionality, but some things are different, right? but we can treat a motorcycle as a vehicle. We cannot treat a motorcycle as a car, but we could treat like a sedan as a car or a truck as a car, right? So just keep that in mind. Polymorphism is treating one object as another type of object so that you can get access to that object through inheritance and casting and all that stuff. And I'm going to show you all this stuff today as well. There are other types of polymorphism, so like function signatures. The example I like to use here is like a print string. So in C# you have a print string function that takes in a constant char pointer as like the base version of the function, which is a common type of way to get the alphabet up in code, right? But there are overridden functions for print string that take in strings. They take in like a UTF-8 character. They could take in different languages, right? So there are like 100 different print string functions, but because they're all named the same, you can just invoke the one that you're using, and based on your parameter list on what you're passing into the function determines which actual function gets called. So we'll take a look at that as well today. And then first thing we're going to do is show you basically everything we covered in lecture before we get to this activity. And then we'll get to this activity and do this together. So let's start out with some code. So let me clean out some of this stuff. All right, so what I did here is I set up a class for us to use an example for our object-oriented programming lecture. I created a vehicle class here, gave it a private or a protected member variable called name. It is a string, and its default setting is Bob. And I added an accessor here called getName, which returns the name variable. It is public, so anybody can access getName and they can use it. It is virtual, which means that other inherited classes, so classes that use vehicle as their parent class, can implement a version of getName if they wanted to. And then we have a mutator here called setName, which takes in a string, and it's going to set our private our protected string here, name, to whatever's passed in here. So we're going to manipulate that data if we don't have access to it, right? So only our children, because it's protected, have access to it. So anybody outside of the class or that is not a child can use this to manipulate that data. Couple of constructors here. So we got a default constructor that does nothing. And then we have an overridden constructor that takes in a name and allows us to set that data member there. And then I added a virtual print function, which just takes that name and prints it to the screen. And the children classes can override this function to implement their own version of print function. Next thing I did was create a couple of child classes. So I got a cart class, which derives from vehicle. It doesn't have any data members, but it does have a couple of constructors. We use that set name from our parent class to set the name that's passed into this overridden constructor here. I wrote a custom function here called IamACar, which sets the name equal to IamACar. And then an overridden print function. There's that override keyword, which will print our own version of the function. And the way it's different is I'm adding this child function at the end of the name. Next thing I did was create a motorcycle, which derives from vehicle. Looks like we got a question. Yes, yeah. Robert said it best. Feel free to ask questions here in chat on anything you don't understand. Robert will take a crack at it and see if he can answer it. If he can't, I will try to answer it myself. So motorcycle derives from vehicle. I set the name to Kawasaki here, overrode the print function, but I didn't do anything special with it. Just make sure that I print out the name of the motorcycle. And then I created a sedan, which derives from car, so even a further derivation of vehicle. And I set its name to IS300 and overrode the constructor to set the name. And then we use the print function, just like every other print function there. Okay, so I'm going to bounce back and forth between the lecture and the C# code, and we're going to take a look. So objects, for what we're talking about in this example in Visual Studio, objects are each of these classes is an object. Okay, and as you can see, it is a bundling of data and behavior. So we have our member variables here, and then we have some functions available to us. This is our behavior, and we can invoke these functions somewhere else in code to run the functionality and get the behavior that we want from this class. Let's jump back to lecture. So that's objects. Classes, pretty self-explanatory. We just covered that stuff. As you can see, each one of those is a class. They do meet all this criteria. They do have unique protection levels. I do want to point that out. We try to use data hiding as much as possible. And then I will show you how to create instances of the class in the program itself. Information hiding, again, we hit this. Some of our member variables are public, some of them are protected. I will show you the behavior in code for this stuff here in just a second. Encapsulation, I can't really show today, so we're not going to be really covering this. There is a way to show it in a couple of days, so just I'll try to remember when I see it, when encapsulation is in practice in some of our later lectures. Inheritance, we did cover that. We have a vehicle-based class. We have car and motorcycle derived from vehicle, and then we have sedan derives from car. So as you can see, we have more than just a parent-child relationship. We have a parent and a grandparent relationship as well. We did override. We use that override keyword on some functionality for our print strings or our print names function. And then we added some additional functionality in the car to set our name to I am a car if we call that function. All right. And then polymorphism, we'll get to that in just a second. So let's take a look at some data protection stuff. So right here in my program, it's just the main function here, and I have a vehicle, and I'm calling new. I'm calling the constructor. I'm actually passing a string in here, so it's not the default constructor. I'm calling the overridden constructor. Then what I want to do is take vehicle one. And I'm going to invoke the print function on it. And then Control-Shift-S to save, Control-Shift-B to build. Always want to build to make sure that I don't have any errors. I'm just going to run the program. And then as you can see, we got here, we're using the overridden constructor, and it's calling Ford. So it's setting our name to Ford, and we can print that to the screen. All right, so if I don't use the default constructor, so if I take Ford out of here and run it, it defaults to Bob, so that's our default constructor there. So just be aware that you can get different behavior based on whether you choose to override or overload your constructor. And then you can even have multiple versions of this. So if I were to copy this here and paste, I can add, let's say, more, let's say if I wanted to take in an integer, I could do that as well. And then I can invoke that function based on what I pass in through the parameter list. Okay, so if I wanted to get that Ford back and pass in, let's say, -1, right? Now I'm invoking that second constructor here as opposed to, or excuse me, the third constructor instead of the second one. but the behavior is just the same. So if I run it, it'll say Ford. Okay. All right, so that's overriding. Let's look at data protection. So I want to get access to names. So we're going to come over here and say vehicle. Get vehicle 1, and then I'll hit the dot. And as you can see here, I don't have access to name. Right? I am outside of the class. The protection level on the variable is protected, so only my children can get access. Right? So I can't get access to that variable. Now, if I were to change that to, let's say, public, be going to throw an error because I haven't finished this line of code. But if I hit the dot now, as you can see with the public variable, I now have access to that variable and I can manipulate it. I can even set it to something like this if I wanted to, right? And then when I run the code, it is now printing 0.5 instead of a name, right? So like I said, with a public variable, I can set whatever I want. I'm taking a float here and converting it to a string and setting that to the name, right? And that's not the function we want from this variable. So what we're going to do is we're going to turn it to private, and I'm going to build it, and it's going to throw another error. And it says inaccessible due to its protection level. And it takes me to some code in the car. And then the other one says over here to the variable where we're trying to manipulate it ourselves. So down here, for the car, the reason it's throwing an error here is because I'm directly accessing name. So this private variable outside of the class. When it was protected, it didn't throw an error because I derive from vehicle. So that's why we have different settings for our data hiding. So when I go to protected now, run it again and build it, the car error is gone. However, we still have the error here because we're trying to manipulate the data of a protected variable. So I hope that kind of shows you data hiding in action. Before we move on, any questions about the stuff we've covered so far? Objects, classes, data hiding. Any questions about that stuff? Okay. All right, so let's go back and check our lecture. So polymorphism, let's take a look at that. Oops. So what I'm going to do here is I'm going to create a bunch of vehicles here. So I think 5 are good, and we'll change the name of these so that Unreal or Visual Studio doesn't complain. Right, and then what I'm going to do is I'm going to change these from a vehicle to some of our derived functions. So I'll do a quick car, a motorcycle, I'll do a sedan, and we'll do another car here. And then each one of them is complaining because it didn't override the function. So now they're no longer complaining, and the motorcycle is complaining now because if you remember, I only have a default constructor for motorcycle, so I can't pass anything in to that. We'll change the car to, we'll say Chevy. Oops. All right, so Chevy for that one. Sedan, we'll say I'm blanking. We'll use the default for sedan. And then for the car, And we'll use Mercury. Okay, and then I'm gonna have to print all these. So let's do that. Two, print three, print four, print five. Okay, so I'm taking all of these derived classes and I'm storing them in vehicles, okay? And the reason I'm doing that is so that I can do some manipulation of each vehicle, right? So if I wanted to, I can say, store all this into an array and then an array of vehicles, and then I could loop through the array and call functions on that if I wanted to. So just to show you that we are using a overridden function. We got child function printing for our car there, and then we got default constructors for our motorcycle and our sedan. Okay. Again, they're treating them as vehicles, but because I changed what class is after the new determines what class that vehicle is, okay? So if I were to change this back to vehicle, right, for the second one, so it's no longer a car, right? We see now that we still are getting the functionality we want, but I'm treating that as a vehicle now as opposed to a car, okay? So it can still run those functions. Let's see here. Now, if I wanted to, I can take vehicle 3, so down here, so vehicle 3, and I've hit the dot on it. You'll see that we get pretty much everything we got with a regular vehicle, right? But if I were to cast this, I want to do a C-style cast here, motorcycle, and I'm going to surround that vehicle and then surround the whole thing with parentheses. That way, I'm basically, these parentheses I'm using to cast. This one is the object I'm casting to, and these outside parentheses are treating this object as that object. So when I hit the dot on that now, we see, well, you don't see anything because the motorcycle doesn't have additional functionality. Let's add some quick. So we're going to add a public function. It's going to return an integer. We'll say get horsepower, and we'll add a member variable here. So integer HP, and we'll set that equal to 600, something like that, right? And then for that function, we're just going to return HP. So I got a public function just accessing some data. So now when I treat this vehicle class as the motorcycle, now I have access to that get HP function, right? But if I were to take the cast away, let me do it a line above, 3. Now, if I take the cast away, as you can see, I do not have access to that get HP function. So this is the polymorphism, treating one object, so in this case, a vehicle, as another object, a motorcycle. So that's because it only works because I create a new motorcycle here, and I'm storing it in a vehicle class. But this is a polymorphism through inheritance and casting in action. So any questions about that? Inheritance, polymorphism, or casting in C#? Okay, so super quiet class this month. Great. All right, so I'm assuming you guys are all good with object-oriented programming. So let's go ahead and move on with the activity. Okay. All right, so the activity, we're going to be opening up Notepad or Notepad++. I like to use Notepad++ for coding pseudocode. There's a link here in the lecture slide for you to download that. It is free to use, free to download. They do ask for donations, so later on when you get a job and start making money, if you like it, by all means donate. Yeah, this is just a review lecture, so you're going to be good with this stuff. I want to refresh your mind on this topic so that when we get to it in Unreal, it's not going to be too crazy. Right. All right, so first thing we're going to do is write in pseudocode together as a class, one class from a real world object. So look around your room and find something that you would think would be a great object that we could pseudocode. So what do I mean by pseudocode? Well, we're going to create the class name, some variables associated with that object, and some functions associated with that object. So I know the first thing listed is a chair, but furniture itself isn't really a good example of a class to pseudocode because it doesn't have a lot of functionality. It just sits there. You could move it and you could sit in it, but that's pretty much it, depending on the chair, obviously. So think of a real world object somewhere in your room or out in the world that you would think would be a good example for a pseudocode. So, and we'll do that in Notepad++. Now, Notepad++ is awesome because you have access to all kinds of things. You can run different languages. So in our case, we're going to be using like C# or C++. You can change the encoding, so what type of characters you want to print to the screen. There are different character sets, so you can use like Chinese or Japanese. I think they even have Icelandic. Maybe, I don't know. Yeah, Icelandic, right there, pretty cool. So yeah, you can do all kinds of encoding there. It has some built-in functionality like an IDE where it does an autocomplete for you. Let's go ahead and create our first class. So if you guys wouldn't mind posting in chat a real world object you would like to see pseudocoded. And the purpose for doing this is to show you what pseudocode is and what you're going to be doing for assignment 1, assignment 2, as well as your pseudocode post for your discussion and reply. So anybody at all, post into chat a real world object you would like to see pseudocoded. Refrigerator, okay, that's a good one. So we'll do a refrigerator, yeah. English. All right, so let's talk about variables. What kind of variables does a refrigerator have? What kind of data can we get from a refrigerator? We'll start with the shape. So it has some sort of shape, temperature, right? Okay, so we have different temperatures depending on how many different areas of cooling we have. So we can do, let's start with our freezer temperature. And then that would be the name of the variable. And then we're going to use a float for the freezer temperature because we can get in between degrees. And then we'll do a float for fridge temperature, the rest of the fridge. I don't know what that's called. The regular area where you keep everything. We do have some sort of materials associated with our build. So what is it made of? All right. And then we have some sort of structure, so dimensions, right? So we can use a rectangle for our dimensions. Okay. What other variables do we have associated with the refrigerator? Okay, so do we have an ice maker? Has ice maker. A Boolean for that. Power consumption. So we'll do joules here for that, and power consumption. All right. How many doors does it have? So we would create, let's see here, an integer array, num doors for that. I think that's pretty good for variables. All right. So good thing to note is when you're thinking about creating variables, it doesn't necessarily matter what you're naming the object, right? So for things like joules, there is no class written for joules, right? This is a custom class. So I'm assuming joules is a custom class. It handles everything related to power or electricity, right? Rectangle is not defined by C# or anything like that. So when you go to do this assignment 1, 2, assignment 3, when you're naming your variable types, right? It doesn't matter if it's a real world class or a class that you define yourself. It can be completely made up, right? And I just want you to think about that whenever you completely make up something. Just assume that there is a class somewhere else in code that is there for you to use. And then name your variables on what they're relating to the variable type and how it relates to the class itself. So dimensions are important. I mean, pretty self-explanatory. What is it made of? Yeah, materials. That's an okay name for a variable. You could have just done a lowercase material there if you wanted to. I do want to see some data hiding. So would freezer temperature be a public variable, private variable, or protected variable? Public, private, or protected for freezer temperature? All right. Yeah, Paul got it right. It's going to be a public variable. And the reason it's not protected is because we're not writing a class that derives from refrigerator. This is a refrigerator, and this freezer temperature refers to the fridge, but anybody can come along and open up the door and see the temperature inside. I mean, it could be protected because you keep it in your house, but I'm going to say it's going to be public because I'm more certain that you can do that. Same thing with the other temperature. Materials, public, private, protected. Yep, public because we can see it. Technically, it would actually be private. And the reason why it'd be private, I'm sorry, is because we can't change it, right? The refrigerator is the only thing that has access to the material. We can't change it outside of anybody. You know, can't just come along and just replace all the material in the refrigerator. They have to be like a technician or an engineer or something like that. Dimensions are going to be public because we can reference that in not only the refrigerator documentation, but we could probably find it online. So it is well known the dimensions of a refrigerator. Has an ice maker, again, that would be public because that is something we need to know when we're purchasing the object, right? Power consumption, we'll say is private because the refrigerator determines how much power it needs. It doesn't really tell you how much power it's drawing every month. Yeah, you see it on your bill, but that's included with all of your electronics. So that we're going to keep private. And then the number of doors is going to be public because, well, no, we can't change that. So again, that would be private. So yeah. So as you can see here, you can change your mind when you're thinking about this logically on whether these variables should be public, private, or protected. Okay. Now, order matters when you're dealing with classes. Now, what do I mean by that? I'm talking about memory footprint of the class. Depending on the size of these custom classes here, will bloat the size of this class refrigerator. Now, if I were to order this, I would probably keep my smaller sized variables up at the top. So like a Boolean or a byte or a small integer or something like that. Now, I know you don't know the size of the memory size, the memory footprint of each of these variable types. That's fine. You could potentially look that stuff up, depending on what language you're in, depends on the size of it. So just keep in mind that we want to be aware of the order in which we're adding our variables to our class and group things together. So keep your floats next to each other, and then arrays are typically at the bottom because we don't know the size of the arrays. They could change dynamically. So right, that would probably be private as well as for dimensions. We can't change them. You're right. If you can't change something, then odds are it should be private. So I may not, like I said, I may not get everything right the first time, but if I logically think through what it should be, and using Max's question there, we were logically able to determine that dimensions need to be private. All right, so now let's talk about functions of a refrigerator. What does our refrigerator do? Keep things cold. So it has a cooling function, okay? So we'll do a cooling function. So does cooling, all right, so let me write down here below our class here. So for a typical function, we have some sort of return type, and then we have some sort of function name, right? And then we have a parameter list. And then the last component of a function is the body itself, okay? So we will not be writing bodies at all for pseudocode. You will not be writing bodies of a function for assignment 1, assignment 2, or your discussion post. I just want to be clear, zero code needs to be written for your functions. I just need to see the return type, the function name, and the parameter list, okay? So for each assignment, that's exactly how I want to see your functions. All right, so cooling is a function name. Do we want to tackle the parameter list or the return type first? Okay, so does cooling, the act of cooling something, does it return anything? What is the outcome of cooling that our refrigerator does? Cooled stuff, right? Well, yeah, you can think about it that way, but really what we're doing is changing temperature, right? So we're returning some sort of temperature, whether that be degrees or, right? That being said, do we need any information to cool an object? We need a float for our current temperature. And then we need to know what our temp setting is, right? So what did we set our temperature to, and what is our current temperature? And when we cool things, this is our new updated temperature, okay? All right, so the next function, is there another function for refrigerator? Well, yeah, there is another one. Well, I'll help you out. Instead of cooling, do freezing, right? So it's the same thing. The temperature controller for both areas are almost the same. So yeah, we get the same functionality. Anything else? Keep stuff fresh, okay? So let's see here. Is there a way we can do that? So keep, trying to think of a way I can write that out. How do I keep stuff fresh? We can write a function called isFresh, and that takes in a food item. Then we can do expiration date. And then let's say that is a date. Expiration date. And then we can return a Boolean. So return types can be custom functions as well. You don't have to return just a typical variable. You can return an entire function, or excuse me, entire object if you wanted to. Temperature in this case would be like a pound define for a float, or we can just replace that and return a float if we wanted to. That's perfectly fine as well. Either or works. That's up to you when you're creating this assignment. And of course, you can always return a bool if you don't want to return void. So a function that doesn't return anything is going to return void. And that would be something like has food, and then we'll do, yeah, just something like that. You can write functions like this for your assignments. However, I would like to see it more along these lines where they actually have a return type, they actually have a parameter list, okay? Yes, one of these is fine, but I want to see the majority of your work be more in this format, okay? All right, so any questions about pseudocode and how to write pseudocode? This would be perfectly all right for a discussion post, and I would probably receive a 100 for this class. Now, do not use refrigerator for any of your examples or assignments, since we covered it in class today. Find another real world object, right? There are plenty of stuff in the world that actually has some tangible functionality that you can easily identify. You can create a bicycle. You can do a cell phone. A cell phone has so much functionality to it that you could spend all day writing all the functions that a cell phone has, as well as all the member variables that a cell phone has. Right? So just think about your assignments and kind of go through the same steps that we did here in order to reach the end of your assignment and receive a good grade. So any questions about discussion post and reply? Cool. So that was the activity we did together. Hopefully you guys learned some new information. Let's move on to the next activity. Now, had we been on campus, this would have been a fun activity where we would have all done this broken into groups and done this in groups where we create 5 classes from a real world object. Okay, so for assignment 1, I'm going to allow you guys to group up if you so choose. You don't have to, and I don't want to, exclude anybody, but groups no bigger than 3 people. So 3 people together, you can write out 5 classes for assignment 1. Assignment 2, I want you all to do it on your own individually. But for assignment 1, you guys can do the 5 classes together. So that way you can discuss your variables, you can discuss your functions, you can discuss your data hiding. And that's one thing I didn't put in here that needs to be in here. Must have data hiding. Yeah, and that applies to everything. I don't know why it's way the heck over there. Won't let me tab backwards, really? All right, screw you. Put you in the middle. All right. Well, it's not my day today, apparently. Yeah, whatever. All right. So today, break up into groups if you want. Write 5 classes from real world objects. I don't want to see code that you previously written in another course. I don't want to see code at all. I'm just looking for class name, 3 variables. Let me put that up there. 3 variables at least. Each of those variables has some data hiding on it. 3 functions. Constructors do not count. Accessors and mutators do not count. And they also must have data hiding associated with them. And then once you're done pseudo coding those out in like Notepad or Notepad++, then you can take those classes, those 5 classes, and put them into Visual Studio in C# and submit that for assignment 1. So any questions about what I would like you guys to do today? Like I said, you don't have to break into groups. You can do this individually, but I would like to see this done today. And if you have questions about the classes as you're making them, post those in Discord so that Robert and myself can give you some guidance. And that's pretty much it for today for the lecture. So before next class, please review the badges. And what I'm talking about badges is that on the drive under the root of the student folder, these 2 badges I'm referring to. Okay. So any questions, any comments, any concerns before we finish up lecture today?
Yeah, I have a question. Can you hear me?
Yeah, go ahead.
So for these 5 classes, you said 5 objects in the real world, and then you pseudocode them, and then put them into Visual Studio, and then upload them for the first assignment.
So for the first part, I would like you guys to use like Notepad or Notepad++ to pseudocode it. And then individually, each one of you is going to take that pseudocode, convert it into C# and post it for your Turnitin. All right. Now, okay, you can work together, but I don't want an entire group using one set of C# files. I want each person to create their own C# files so that you guys get familiar with doing this stuff in C#. Okay. Does that make sense?
Yeah. And you said it doesn't have to, it has to run, right? But you said it doesn't have to return anything?
No, it doesn't have to run. So so if I were to take all this stuff and open up Visual Studio.
Okay.
We'll just use this assignment that we have here. And then what I'm going to do is I'm going to create file, go to new, go to new file. And I'm going to find C#, Visual C# class here.
Mm-hmm.
I'm going to open that. And from there, I can just come in and replace all of that with the class that I have. And then obviously tab everything over. Oops. All right. Now it's complaining right here because class is using a capital C, and anytime you have to write classes, you do that in here. So yes, you could totally just copy and paste, and everybody could copy and paste. That's perfectly fine if you do it that way. Yeah, I'm okay with that. But I want each of you to create your own, make changes if you want, and then submit those individually. Right?
Okay. That was my only question. Thanks.
Yep. Any other questions, comments, concerns? Awesome.